Hi, my name is Josh Bongard. I'm currently a professor of computer science here at the University of Vermont in the US. And I was asked by the conference organizers to try and answer three questions. The first one is, what sparked my interest in A-life research and how did I get started in this field? I grew up in Canada and I did my undergraduate degree at McMaster University in Hamilton, Ontario. And while I was studying for exams, after my first year, I was wandering around the library and by accident stumbled across this book, Genetic Programming, written by John Koza. And as I flipped through this book, I learned about this idea of evolutionary computation, that you could actually write a computer program that would evolve other computer programs. And that idea absolutely blew my mind. I was studying computer science, but not biology. And this sort of clued me into the fact that there was something amazing happening at the intersection between biology and computer science that my professors had not mentioned at all. And that sort of sparked my curiosity. So after my undergraduate, I really wanted to pursue this idea. There were no programs in artificial life at that time anywhere in the world. But I did find the EASY program, the Evolutionary and Adaptive Systems program at Sussex University in the UK. So I went there to do my master's degree. It is one of the best master's programs in the world, in my opinion. It's an interdisciplinary master's program. They invite biologists, computer scientists, budding philosophers, psychologists, and mix us all together to really study all of these interesting questions, many of them A-life related, at the intersection between biology and computer science. After I finished my master's degree, I had met at that time Rolf Pfeiffer, who was then a professor in Zurich at the University of Zurich, and he was studying robotics, which I hadn't really been exposed to up at that point, and learned about not just evolutionary computation, but this idea of evolutionary robotics, that we could take evolutionary algorithms and instead of having them design disembodied computer programs, we could have them design embodied intelligent machines, otherwise known as robots. So I did my PhD with Rolf, and that became my subject of study to the present day. When I finished my PhD, I wanted to return to North America and was very fortunate to get a postdoc position with Hod Lipson, who was then at Cornell University in upstate New York. And we worked together on what eventually became known as the Resilient Machines Project, which was to figure out how to allow machines to learn and recover from unanticipated situations like physical damage, like you see here. When I finished with Hod, I was very lucky to get a faculty position at the University of Vermont, where my students and I continue to this day to study embodied cognition and evolutionary robotics. Second question we were asked to respond to is, what is your most exciting or surprising artificial life findings? And for me, that's probably the Xenobots project. This is a relatively recent research project between my lab and Mike Levin's lab at Tufts University. In that project, we used an old idea from artificial life, which is to evolve virtual creatures. In this case, you can see an evolved virtual creature. This creature is made up of a whole bunch of voxels, or 3D pixels. And each one of these little voxels is a model. It's a biophysical model of a very small piece of frog tissue. We asked our A-Life program, in this case, to evolve a virtual creature that moves from the left to right as quickly as possible. Came up with this design. And our microsurgeon on this project, Doug Blackiston, then cell by cell built an actual version of this virtual creature using actual frog cells, which resulted in the millimeter-sized physical xenobot. I don't have time to talk more about xenobots today, but if you Google it, Xenobots, xenobots, you'll find lots more details about that project. Third and final question that we were asked to address is, what is the one big unanswered question in artificial life that you think could be important to the future? My question, which I formulated long ago and is still a question for me, is why is robotics so hard? And why is AI so easy? Not that AI is easy, but it's clearly easier than robotics. We now have ChatGPT, we have Stable Diffusion, we have some very sophisticated and impressive AI programs. But at least for most of us, we do not have robots working and playing alongside us here in the real world. Why is making embodied machines so much more, why is making intelligent embodied machines so much more difficult than making non-embodied intelligent machines? Just to give you an example of this, I asked ChatGPT the following question: what would a sustainable carbon neutral community for 1,000 people look like? And ChatGPT gave me back a very good answer. It explained what that community would look like. It would encompass several key aspects and so on. I then followed up with a second question, which is design, build, and run it. An embodied machine, at least in theory, could reach into the world and try to build different things. It could push against the world and see how the world pushes back. It could learn from its mistakes and get better and better at making things happen in the real world on behalf of humans. We have not yet figured out how to make intelligent machines do that. And obviously, ChatGPT certainly cannot. When I asked ChatGPT this, it said, as an AI text-based model, I'm unable to physically design, build, or run a sustainable community. So I would say part of the mystery of intelligence has been solved. We've gotten better at making non-embodied AI, but making embodied AI is much, much harder and is still an open question in the field. And there is a lot of room for all of you up-and-comers to learn about embodied cognition and try and come up with your own answer to the question of why is robotics so hard and AI is so easy. So that's a bit of my story, and I've been in the A-Life community for 24 years now, and I hope you will come and join us. Thank you.